Good afternoon, everybody. How are we? Good show? All right. We show you about 1 million ways to spend money in the basement. Now I'm going to tell you how to make money. Right? How's that sound for a change? You like that? So last year we told you the advantages of bringing alignment equipment into your facilities. And what I'm going to focus on this go-round, again, is how to put that equipment to good use before, during, and after the repair process, okay? So as many of you know, you hear the buzzword blueprint all of the time, and that's what we're going to try to focus on, okay? Blueprinting our work before, during, and after the repair process. All right, a little background. A lot of you know me. I see a lot of familiar faces. Bring you up to speed. I've been with Hunter Engineering for about 16 years now. Prior to that, I worked for this little teeny tiny insurance company by the name of State Farm for 7.5 years. I was their trainer, property claims trainer. I also worked as a service first, select first, and eventually I made my way into subrogation. And that's where I got an ugly taste in my mouth with the industry. And I decided to pull back my role and go full-time into training, okay? I was an ICAR instructor very early on, early 80s. And I got out of that about 2002 to do this full-time. During my different paths in the automotive industry, I've received a lot of training from a lot of good people, and that's what I try to mold my training around, is stuff that's direct from the original equipment manufacturers and the engineers that actually work behind the scenes with this stuff. So I'm a lucky guy. By the way, there's my contact information if you guys want to take a minute and jot that down on the materials I give you. I love emails. I love text messages. My phone. You know, if something is on fire and you're trying to phone me with a 911 thing, I'm training all day long, so please leave me a message, a detailed message if at all possible. I'm going to throw this out there, even though you don't have Hunter equipment, you can still contact me. I hate to see technicians, shop owners, estimators, whatever, struggle out there. And my obligation to you is if you call me with a question, I will give you the answer, not just a answer. Right? That's the problem with steering, suspension, and now ADAS. There are so many self-proclaimed experts in these fields, and it's getting really confusing, more and more confusing all the time to make educated business decisions, okay? So with the 3 books that I've given you, I hope it's going to bring some clarification to all of that, all right? These are weird times. If anybody was at the Atlanta NACE convention this year, I was the guy that stood up and told everybody, hey, the sky's not falling. That we just need to change a few things and adapt. And one of the big problems that we have in this industry is finding technicians. Would you all agree with that? Who has too many technicians in their shop right now? Wow, no hands in the air, right? So what kind of a technician does it take to do this work? Before we get started, I want to clear the table there. You guys that hire folks, you need to look in different places. Most of you guys are familiar with the VOTEC, college level. You go to the auto shops. Some of you sit on steering committees. I hope a large percentage of you do, because they really need your help there in the steering committees to pull our forces together, because they have to contend in these schools with other folks out there, okay? So, having said that, while you're there visiting the auto shop program, tippy-toe down to the IT department and look at those kids working on the computers right now. There are 1 or 2 gearheads in there that love to tune up Hondas, BMWs, Nissans, whatever, and they've got the computer skills that we need, and they have the most important skill set under their belt, which is the ability to read at least on the 8th grade level, right? Because everything that's on the equipment that I'm showing you here, we have to dummy it down to that level because that's the reading level that's going to capture a technician's attention, which is almost pretty sad. Stop and think about it. But you have to read, okay? All right, so please contact me if you're struggling with anything. All right, so we're going to open this up primarily working out of this book right here, okay? Wheel Alignment Guide for Collision Appraisers. Let's open that up. And I want you to go kind of out of sequence here, but go straight to page 2. I think all of you guys would agree, not all alignments are the same, right? Okay, so we break it down into 4 different categories. Maintenance alignment, right at the top. That's where we adjust the factory adjustments only, okay? How many of you folks are doing alignments already? And the rest of you are subletting? Let me tell you something, that's a bigger show of hands for having the aligners in your old shops than I had last year. So there's already the big change there. What do we call that maintenance alignment? Come on. Set the toe and collect the dough, right? Does that fix everything? No, okay? Sometimes we have to do a little additional work to get things to work out and have a happy ending, right? In some cases, we need cam bolts and other aftermarket kits that are complete standalone operations. We're going to refer to that now as a corrective alignment, all right? Now, having said that, let's figure out the difference between those 2 alignments. Grab this book right here, the Wheel Alignment Adjustments Guide, and let's take a look at, what's a big seller out there? Let's say Toyota. Does that work for you guys? Okay, so let's see what's going on with Toyota these days. Go to pages 69 and 70. The book is self-explanatory, so let me explain it to you. Okay, right up the middle, we got year, make, and model, right? Over here on the left-hand column, that's how we make our adjustments. Over here to the right is the safety systems resets that are required after an alignment. In other words, those manufacturers have the position statements that says this has to be done in addition to making the other corrections. All right, now over here in the adjustment side, you see where it's gray? That's a factory adjustment. Do you see where it's blue? That's an aftermarket kit part or procedure that is a standalone operation that is not included in a normal maintenance alignment, okay? What do you see the most of there, guys? Gray or blue? Blue, which means what? I like you said money. That's exactly the way I want you to look at it. You see, the average maintenance shop out there looks at that as a, oh man, I got to put a cam bolt in this thing? No, I'm just set the toe and kick it to the curb. So you see the total difference between a maintenance alignment and a corrective alignment. Now you folks that are subletting alignments, you're probably getting a little bit of a break. So you probably feel like you're making, $20, $30 every time you do an alignment by subletting it, right? Do you think they're addressing this over here? Now let me put the fear of you-know-what in you and ask you over here to the right, do you think they're actually performing those safety system resets in the tire maintenance? No, that industry, there are 3 camps. I'm working hard trying to get the message out, especially with our customer base, that this stuff over here needs to be taken a little bit more seriously than we have in the past. Because when the John Eagle lawsuit, everybody's familiar with that, right? We had a sad day yesterday. But when that happened, that set up case and precedence. If you're not following position statements, see, that's how that law was, that's how that case was won. So if you're not following position statements while you're repairing a car, collision, repair shop, tire store, from here on out, because of that, it does not matter. It's already been resolved in court. You neglect to do this, somebody gets hurt, killed, property damage, what's going to happen to you? Yeah. Now, if you're subletting, you can't say, well, I took that down to Marvin's garage. Marvin was responsible for that. Okay? When I worked for State Farm and we had the estimate and you received your draft for payment, the check was made out to the body shop, not to Marvin's alignment. Everybody clear on that? So I used to run around saying huge liability, sky is falling. All I'm going to say now from here on out is you're running a real risk subletting this kind of work out, and just let it go at that. I don't think I have to beat that dead horse anymore. All right? So if we look at the third type of alignment that's up there, modified, it gets even stickier because a lot of folks are raising and lowering vehicles, right? Now, your average repair shop will perform maintenance alignments, and there are, you know, maybe the top 25, 30% of the cut out there will do the corrective alignments, okay? And they're definitely into the modifieds. They're just now figuring out that if you're modifying the vehicle, they're in the same boat as the collision repair community. So since we need to have this stuff reset after a wheel alignment, we're now really trying to educate the tire stores, multiple shop owners, covering up the modified guys. Of course, there's a lot of that here at the show, and we've had a lot of activity at the Hunter booth, people running up going, what do we do? What do we do? What do we do? So, and as I've been talking to people here the last couple of days, and the last couple of years, really, I've got a hold of these modified guys, and they don't realize that when you elevate a F250, 350, 6 inches, that's got a camera up in there, that camera might see over, you know, one of the lower vehicles that would be out there. And what does that camera run? Well, it's lane control, pedestrian recognition, color recognition, size recognition. You know, if it sees something getting closer, that means what? It's getting bigger in the camera. So the size recognition is really critical, but where that camera is aimed is even more critical. I mean, at the end of the day, you're dealing with autonomous braking. What could possibly go wrong? Yes, okay? So, printed material. You know, I've already had a couple of sidebar conversations with you. They're like, John, you work both sides of the fence. You know, how do I negotiate with my insurance companies, be them a DRP or whatever? You know, there's some lines that we cannot cross, as everybody knows, but we can have open dialogue about diplomatic negotiations and relationships. When I came into your shop as an estimator and you were asking me for something, what did I need? I needed documentation and evidence where the damage is at, okay? So this is going to begin some of the documentation, and some of you guys are, well, that's great, John. What happens when I walk out the door and the next publication becomes available? It doesn't matter if you have an alignment machine, because all this information is in the alignment machine, including the position statements that you're going to need to print and hand to the insurance adjuster or estimator or claim rep. Or you can even take pictures of this stuff and marry it to your, you know, your electronic platforms. Our software is vehicle specific, all right? So in other words, as soon as you select the vehicle, like let's say a 2012 Toyota Prius, let's look at that one. What all do I need to do to that vehicle? That is on, let's see, bottom of page 68 in your adjustments book. What do we need for that 2012 Toyota Prius according to this book? Let's say I have a camber issue in the rear, camber issue in the front. What do I need, guys? Cam bolts and shims, all right? Now, if you read into the safety system reset for the 2012 Toyota Prius, what safety systems do I need to reset there? To the right. Electronic stability control and what? Lane departure warning, okay. So those are two systems that have to be done after a corrective, after a maintenance, after a modified, and of course the number 4 alignment is the one that concerns you guys, the collision alignment, okay? Now, this is strictly for maintenance and corrective. If you're dealing modified and collision, you may have to do some further investigation, but at least you know that this much has to be done for the norm. And again, I'm going to go out on a limb, and I'm going to tell you that my experience as a trainer, and I get all over the country with this, and 2 weeks ago I was up in Canada delivering the same messages. Hardly anybody's taking this serious. They don't follow through. So in the beginning, with our equipment, since it's vehicle specific for this car, we're going to give you the position statement for the steering angle sensor reset, and there's also, even though we don't do it, there's a position statement about that camera too. So that's why that's in, well, as soon as you select the vehicle, it automatically comes up. Reset required, right. That's the position statement where it says reset required. See, that's not Hunter Engineering telling you that you need to do this. That is Toyota, and it's year, make, model specific. Now, having said that, if you have a Hunter machine, those position statements are only good if you keep your database up to speed. Because a lot of guys, they only want to do their databases every 2 or 3 years. I'm just going to say straight out, that is not a good business decision. You don't want to save $500 or $600 on your subscription because one car gets by that you didn't perform the required safety system reset, and it could be John Eagle all over again. So we want our customers to stay in business, number one. Number two, we don't want you to be afraid to do this work. Everybody's like, oh, I don't know if I want to get into this. The liability. Well, the liability is already yours once you've received that check, okay? So that number 4 alignment, though, is actually my favorite. I was the technician, did my framework. When I first started, we were using self-centering gauges back in the day, and this gentleman came into my shop by the name of Pat Lyons. I don't know if anybody in the room knows Pat. He had a motorcycle accident years ago, and that kind of took his, and changed his life. But Pat come in with his outfit called Nicator and sold this pulling equipment called a Data Liner Pro Finish 80. It was one of the first laser machines out there. And I prided myself on my framework and how I could get things in with that laser beam back in the very early 80s. Okay? I would ship the car off to the alignment shop, and then they would call me back saying, John, your frame's still bent. I'm like, where'd you draw that conclusion? Right? So back the car would come. The angle they couldn't get in was, of course, caster, which we battle with all the time, and camber, of course, but caster was out in this situation here. So my boss man's exact words were, re-rack the car. I want to see it for myself. He says, very few things get by you, John. I trust you. You say you did it good. But if I see it with my own eyes, I can go back and bark at these boys for you. So we benched the car. And anybody that remembers that machine, it was an erector set built underneath of the car. And it took quite some time to get that fandango done. So I racked the car. 2 hours later, we're sliding the laser all over the place. And then when I'm doing that, I'm like, that control arm looks a little weird. So I took a tape measure to the control arm, and I'll be darned if it wasn't bent, okay? I'm like, wow, super alignment technician over there should have picked that up, right? Yeah, no, they're in such a hurry because back in the day, we were making it so we made X amount of dollars by subletting it to that guy, and we had to drive the car across town, so they were able to give us a break, if you will. So what type of alignment do you think that they were going to give me for that kind of money? That is going to be a maintenance alignment. That's exactly what they did. Long story short, I put the control arm on, and I drive the car over there. And what do you think happened? Went right through. So as I drove the car back, I'm a little mad because I've wasted all of this time, energy, money wasted on my end. My boss man didn't make any money on me. And I finally went back there. I said, this vehicle's done. Need to send it off to detail and wash. When are we going to buy an alignment machine and end this drama? And he was like, I was kind of hoping you were there, because I used to tell him I didn't want to have that alignment machine. I wouldn't make any money, blah, blah, blah. I was making every excuse to stay out of it. And then finally we did get our own alignment equipment, and that's how I came into the game. I believe it was 1981. Okay? So, I've got a little method here that's really good for trying to find the bent parts with the steering and suspension components. All right? What I'm going to do here this afternoon, I'm going to teach you about the diagnostic angles that most machines are capable of. All right? I don't want you guys to think that you're here to hear a Hunter sales pitch. If you got a John Beam, they're going to do this as well. It's just we have different ways of approaching it. One machine's a little faster. Not going to say who it is. One machine is a lot more vehicle specific. And one machine is a lot more easier for the technician to use and more compelling because we tell you what you need to do before, during, and after the alignment process. All right? Okay, so in the case of a wrecked car, I like to have information. Now, the sources of information, they're back at the beginning of the other book. What you want to do, you want to try to interview the customer, figure out everything that happened to this car, right? How many times you guys get a car in, facts of the loss are, car was hit, parked and unoccupied, right? You all see what I'm setting up here? Okay, would that car need an alignment? Probably, you know, if it was just backed into in a parking lot, probably not. Okay, well, what if the car was smacked so hard that the tires were locked on the road and the stiction put a lot of energy on the little teeny rods that are up in there? Could the alignment geometry have changed then? All right, what if you talked to the customer and found out, well, that thing was hit on the left side, as you can see. However, it was pushed into the curb on the right-hand side, and you walk over and there's two gouges in each of the front and rear wheels on the other side. So gathering that information can save you a lot of drama and minimize your supplement, which cuts down on cycle time, which is what this equipment is really all about, okay? Good road test, and then we begin our inspection. So you want to give it a good visual inspection, but a lot of this stuff looks bent from the get-go, right? Especially tie rod ends, you know, steering arms on knuckles and so forth. So visual inspection is not going to pick up everything, and I'm going to demonstrate that as we get to the diagnostic angles. So we need these measurements. Now, what I'm trying to encourage people to do, and it's starting to get a lot of traction, especially in the insurance side of things. If we do a quick check, running all the diagnostic angles in the beginning, and with the little bit of information I'm going to feed you here today, you should be able to put two and two together and know about that control arm before you send it, or, you know, we're at the beginning of the job, I can order the control arm now instead of waiting for it, right? Because every time you need a part, you can call any dealership any time of day and get that part delivered right away, right? Yeah, if that's a lower control arm on a GM, it might take a day or two because everything's on intergalactic back order because of the strikes, right? But it's not just GM having problems, it's everybody. Parts are a real show, they really are. So if you pick up on it in the beginning, we can add it to the estimate, get the part in here, car goes through the flow a lot faster, okay? That was basically our seminar last year. But I just want to make you guys aware as a group, if you haven't stopped by our booth or didn't see last year's demonstrations, we have portable equipment that can go with your aligner. And the aligners themselves nowadays are a lot more portable than they used to be. So some folks have an estimating lane, a calibration lane. If you've got a nice clean area that's semi-level, You can lay down these turn plates and do all of these angles I'm about ready to go over with little to no drama, okay? So there are actually 3 or 4 different setups that we can show you down there. I'll be back down there tomorrow. Steve Lemla is our product manager for collision repair side of things, and HD, he's down there working with us as well. Okay, we can talk to you about what you may need to do to get it updated for this work, okay? All right, so our basic angles, most of the tire stores will do these angles. Camber, caster, and toe. But I've seen a lot of cases, again, where the toe is out of specification, caster's way out of specification, and all they do is set the toe, get it in the green, and then they give you a printout that just has camber, caster, and toe in the front, camber and toe in the rear, and that is not going to do any good for anybody. When I came into your shop from the insurance side, if you handed me that printout that just has camber, caster, toe in the front, camber, toe in the rear, that is a maintenance alignment, okay? And that's what they quote for that blank 95 price. And a lot of times that's for a thrust angle too, which I'll go into here in a minute. Now, a good collision where I need my diagnostic angles, steering axis inclination, included angle setback, turning angle, max steer, wheelbase. All right, this is what they do. If I've got a camber problem, the angle I want to look at is SAI and IA. I'll explain these angles as we go through. I'm just giving you an overview right now. Setback is what I'm going to use for a caster problem. Okay, turning angle. That is a diagnostic angle that I'm going to use to find bent steering arms. And wheelbase, we can pick up a bent frame. We also have a body suspension dimension audit where I can use some targets that go onto the body so I can see where the suspension system is in relationship to the body and framework of the car. Okay? I see that we got a number of cell phones I need to collect up. I don't want anybody photographing this. No, just kidding. Please take all of the snapshots you want. I'm not that guy. All right? So here we go. The steering axis inclination. And let's jump back to our other book so it's a little easier to follow. If you jump ahead to page 15, we can follow through this real quick, and then we'll be going back and revisiting this when I come back for the details. So the steering axis inclination, it's measuring anything that holds your pivoting points to the car. Now, when you have a camber issue, you got to break the parts in half. When I say pivoting parts, those are the parts that actually move when you steer the wheel. Okay? So the pivot points in this case here, this is a McPherson strut suspension. So my upper pivot point is my upper bearing. Lower pivot point is my ball joint. Okay? So the steering axis inclination is everything that is holding those parts to the car. Let's take a look at what we have. Again, I have a ball joint down here. What holds the ball joint to the car? All right, what's the lower control arm bolted to? What's the cross member bolted to? Okay, and then up here, we have that strut bearing, which is held with the strut tower, which again is welded to the unistructure. So in other words, to break it down and make it easier in your head here, it's every part that's in the gray up there is your steering axis inclination. Included angle, included angle, those are the parts that are between the pivot points. So in other words, in this case here, I got a strut, a knuckle, a hub bearing, right? And also if my ball joint stud bends, all of the parts are going to appear to move between the pivots. So that's why ball joint stud is in there as well. Okay? Wheel setback. Some machines measure both front and rear wheel setback. Rear setback is an angle that's going to help me with my rear thrust values and all of that. Front setback, though, I'm going to use that to diagnose problems with caster. Of course, you got your turning angle, also referred to as toe out on turns at 20 degrees, also referred to as acromen. Have you all ever heard the term acromen before? Okay, here's what acromen is. Your inside tire is designed to turn a lot sharper than your outside tire. Why does that need to happen? Inside tire is turning a sharper circle, good, okay? So that's why that needs to happen. And the way that that happens, it happens by having that steering arm right there. You ever notice they have a little bend and they up and down? That angle is critical to make that happen. Now let me give you a scenario. Car gets punched into the tire, right? That steering arm bends, what angles are going to change? Well, your toe is going to change dramatically. What do you think they're going to do down to the maintenance alignment shop? They're going to adjust the toe so I can lengthen or shorten that tie rod to accommodate the bent steering arm, right? All right, so somebody that's not on their A game, 3/4 of the technicians out there, I guarantee you, unless they've been to our training seminars, don't even know this angle exists, okay? All right. Max steer, that's where you go lock to lock, and then the machine does a cross comparison of the numbers. That's where you would pick up any internal damage inside the rack, such as a jump tooth, broken tooth, anything that could be out of time or out of sync. And, you know, sector shafts are twisted on some of your older products and so forth. Damaged spool valves down inside the rack. I mean, how many times have you guys had a rack that you know daggone well is damaged, but the adjuster is standing over your shoulder going, I need evidence. I have no evidence. I can't see inside that rack. If you can explain to me or document that there's damages inside that I can't see, I'm all for it. So that can show up in the measurements. And we got you on that one. Body suspension dimension audit. Those are the targets I was talking about, these little square guys, all right? Some of you have older equipment like this. Some of you have the new equipment that clips into the tires. We call that our elite system. No matter which system you have, as long as it's a target system running 9.0 software, which is really old software, you shouldn't be running that at all, really. The point I'm trying to make is even some of the older stuff had this capability, and we just didn't know what to apply it towards. But as you can see, I got targets on the wheels, targets on the body. I can now see where the body is in relationship to that wheel. Okay? Wheelbase, again, could pick up some frame damage and all of that. Most of us old timers used to use that tram gauge, right? Put it in the middle of the wheel in the rear and walk it to the front. But if your steering wheel was turned every so slightly, that really messed that measurement up, and it was worthless when it's all said and done with. Now, when we measure wheelbase on our machine, it's done through the digital imagery, and it's all relative to center line and steer ahead. So you get an accurate wheelbase, which you can get in both millimeters or inches. You can program your machine to go both ways. All right, so let's get an understanding of some of the basics. Flip back in your book to the basic angles beginning on page 5. Now, in order to understand the diagnostic angles, you need to get a grip on the basic angles first. All right? Camber is the inward and outward tilt of the top of the wheel, viewed in relationship to true vertical, which is that blue dotted line going up the middle there. It's not the center line of the tire is what we're comparing to that true vertical. Most camber specs in the front range anywhere from 0 to plus or minus 1. Most cars with strut suspensions have negative camber. Some of the older stuff, solid axles, short and long arm, had positive camber. So depending on if it's a low sprung vehicle or a high sprung vehicle, you're going to see both negative and positive even still to this day. Not everything is set at 0, is it? Most McPherson strut systems are set up negative. So see how that tire is leaning in at the top. Why do they do that, guys? What's that? Well, you would think. If the tire stayed in that position, what would happen to the tire? It'd wear the outside edge slap off. That doesn't happen in most cars unless it's out of specification. What's going to happen when that upper spring compresses? What's going to happen to that tire? It's going to kick out. right? So camber is a very dynamic angle. And to the tire store that will tell you, oh, it's just a little bit in the red, that's not a real good thing, okay? There's no such thing as a little bit in the red. What I'm going to teach you here now is red is bad, green is where you want to be, but a green number is not always a good number either, okay? I look at things reverse. I say it's just barely in the green. That's an issue. We need to get it closer to the middle. You know, we don't want too much positive on one side, too much negative on the other. You're going to learn here in a minute that's going to cause a pull force. Looking at these individually, though, individually, what camber means, if it's in the green, it means you're going to get reasonable tire wear. If it's in the red, what do you think that's going to mean? Yeah, premature tire wear, okay? Where's it going to wear? Again, if it's too negative, it's going to wear on the inside edge. Too positive, it'll wear on the outside edge. We used to get away with a lot of camber. You know, when tires were like 185, 175, 70, 15s. Skinny little tire, right? How big are the tires nowadays? Yeah, 275, 305, 325. I mean, the wider the tire and the more aggressive the tread pattern means the faster this car is going to wear tires. And there's a lot of old timers out there that don't realize the difference in the tire. You know, the tires have gotten much larger, so little problems add up to what, guys? Big problems, okay? And the devil is always in the details. There you go. Okay, so there's any red going on there, just remember that's tire life, okay? Now they're going to come at you. Is this accident related? How would we know if that camber issue is an accident related problem or not? It's easy. Look at the tire. Is the tire worn on the edge? And if it's not, what did you just learn? This is new damage that needs to be addressed, right? I can tell you when I worked for that insurance company, a lot of my complaints happened 6, 7 months after the accident, and it was all due to tire wear. And then we'd go back and find out that the maintenance shop overlooked camber, and of course everybody would scream at me, you guys should never pay for that. No, we'd pay for it if you documented it and asked for it correctly, right? You see where I'm going with this? All right, so if it's in the red, it is an issue, needs to be addressed. It will lead to edge wear, even on the skinny tires. I picked a skinny tire for that picture just to prove that camber will damage that. Now, how do you tell the difference between camber and toe damage? Camber is smooth to the touch. Toe damage is very wavy and choppy. Will caster wear a tire? Not directly. See, camber is what we call a direct tire wear angle. What that means is it will wear a tire while I'm driving in a straight line. Now, it seems like we're driving in circles all day long, right? But we primarily drive in a straight line. So whichever way it's leaning, it's going to rip it up. Here's the other problem with camber. They have to be fairly even from side to side. If they're not even from side to side, that's going to create a pulling force. As you can see, that tire on the top slide there, portion of the slide, is kicked in. It's too negative. So that's actually going to push that car off to the right. See how she's kicked out now? That's going to make that vehicle pull to the left. The easy way to remember this is camber will always pull to the side most positive. So your high number is where it's going to pull, all right? Usually if the car is pulling, it's camber, caster, or a damaged tire during the course of the alignment. But if you come to our 2-day damage analysis class, which we teach all over the country and Canada, that damage analysis class will teach you that there's 9 different things that causes a vehicle to pull, and we give you diagnostic flow charts for all of that as well, okay? That didn't make it into this presentation because I've only got 2 hours, and if you're getting the gist of where this is going, I'm going to have a tough time getting it done before 7 o'clock tonight, so I hope you guys have no plans. Just kidding. So your front cross camber is the bar graph in the middle. If that bar graph is red, you've got to pull. If it's green, it's not going to pull. Now, here's something else you need to know about a camber pull. Camber pulls are highway speed pulls. So if you just driving this car around the parking lot or even around the block, I know some of you guys like to take all right-hand turns and get right back in, you're probably not going to feel this pull force. But once you get out there on the highway, 50, 55, 60, 65, 70, it's a handful. How fast do people drive on a normal basis? 75, 80, 85, 90, 95. Where I live in Charlotte in the southeast, you know, we got some high traffic areas, but they're thinned out. Nothing like California or Northern Virginia or anything like that. And there's times if you're not doing 95 miles an hour, they'll pass you so fast that just about tear your paint job off the car. All right? So any more than a half of a degree, again, is going to cause a pull to the side most positive. Now, just to let you know, there are some cars out there that are a lot more sensitive than this, right? The very first one I encountered was the 2003 Dodge pickup truck. When they put the 20-inch wheel package on there, that became a very sensitive platform. 4/10 is enough to make it pull, okay? So the machine will tell you through the specifications where the level of sensitivity is for cross camber. Caster, that's a nightmare of an angle force, but it's also where the car gets all of its handling properties from, okay? Caster on an average range is like 2 to 5, but what I'm starting to see happening now, where the older cars had much less, and I thought 2 to 5 was bad, now we've got 5 to 10 degrees of caster. That's a lot of caster, right? Now, what does caster do for the vehicle? Directional stability, good, that's one trait. What else does it do for the vehicle? The return of the steering, is that important? Okay, so by design, when I turn the wheel, I let go of the wheel and it automatically comes back. That's actually a DOT safety requirement for anything sold in the United States past, I think, 72 or something like that. Now, let's see what's changed about caster over the years. As you can see, I got 3 casters up there, 0, negative, positive, right? You will never see 0 on a normal car. Why 0 is straight up and down, kind of like my body. I'm standing here straight up and down, right? Pretend my arms are axles and my body is my axis. As I make left and right-hand turns, my arms here are remaining level with the ground. Everybody see that? Okay, not good for stability. At about 20 miles an hour, you're going to do this, go all over the place, and again, you'll never see it on anything that's on the road. Off-road equipment, yeah, all day long 0 caster. You're not driving that stuff over 20 miles an hour. Now, the older stuff has negative caster. Boom, a forward tilt. I've got a 67 Camaro, right? That thing is pretty wild to drive. Now, when I make a left-hand turn, look what happens to my arms. Right-hand turn. Look what happens to my arms. Okay, back to center point. Let's make a left again. Where's all my force and weight at, guys? It's underneath of my right, lifting and making that car easy to steer, which is good because my 67 Camaro does not have what? Doesn't have it, doesn't need it. Now here's where it gets weird. After I make that turn, if I'm driving that car like any normal car of today and let go of the wheel, what's going to happen? It's going to keep going to full lock. Does that sound a little dangerous? Yeah, so like I said, DOT said we have to have an automatic return to center point because we were having a lot of head-on collisions and cars flying off the road. Dangerous. Then we came in with positive caster. Here's the big change. I'm now going to make the left-hand turn with positive caster. Now where's all my force at? It's over here on the left, making it hard to steer, but that's okay. Pretty much everything out there now has power assist. Let go of the wheel, what happens? Automatic return. Okay, so an individual caster up here, if you're making notes, if the caster is in the green individually, what that means is you're going to experience good steering and a good return. Okay? If your caster is in the red, that's bad steering and return. If your caster is too high, it's going to be hard to steer and the wheel's going to snap back. If your caster's too low, it's going to be easy to steer, but you're going to have to grab the wheel and bring it back like we had to do in the old days of my 67 Camaro. Okay? Is steering important? Yeah. That's probably the most important trait that we deal with caster, but there's a couple other traits that are important with it as well. Directional stability, returnability, and enhances cornering. How does it do all of that stuff? Well, it does it through that camber roll that happens, that I just demonstrated here with my body. Mostly everything that you're going to deal with should have the positive caster, like I said. All right, so we're going to measure setback to figure out what's going on with this if we have an issue with it, and I'll show you that here in a little bit. But as you can see, that positive axis is what promotes that returnability, especially cornering. Okay, so your tires, when you turn, don't always just go left and right, okay? Camber roll is something in there that's going to change as soon as I turn the wheel. So in other words, your wheels are turning and cambering at the same time. So what typically happens here, there's your camber roll. So what typically happens, your inside tire is going to go positive, outside tire goes negative into a turn. Can you see how this is going to assist with cornering? Okay, so that's very important to it. The directional stability comes from your cross caster though. Those numbers have to be even, or at least within 1/2 of a degree. Right, so that little minor bend in the control arm, guess what that's going to cause? A pulling force. So a green number is not always a good number. Now, the difference here is caster, just like camber, is a high-speed pull, but it doesn't pull to the high number, it pulls to the low number. Okay, so you see this book's got a lot of good information to keep you on track and not get stuff backwards. All right, so more than 1/2 of a degree difference, again, is kind of the canned rule there. You will see some cars that have specifications that go all the way up to 1 degree, and again, you're going to see some vehicles might have a cross camber spec of 4/10. So they're not all the same as you go out there, like it used to be back in the 70s and 80s. All right, now the last basic angle, our toe. Now toe is measured in 2 different ways. You got your total toe and you got your individual toe. What is the most critical angle here? It's total toe, all right, not individual toe. As you move the steering wheel, your individual numbers will change. So when you set the steering wheel straight ahead, what we're supposed to accomplish, most vehicles have the positive toe that you're seeing down here, which means less distance in the front than there is in the rear, right? Why do they set it positive? What would happen if it stayed like that? What would it do? It would burn the edges of what? 2 tires. That's why there's so much emphasis placed on your front total toe. It's a direct tire wear angle. It's the fastest tire wear angle. If you're off just a 1/10 or 2 in toe, it's going to shred 2 tires, and that'll be the customer that calls you back in like 5 or 6 weeks saying, I'm noticing my tires are wearing funny. It wears that fast. And a car that gets drilled in an accident, that thing, toe really gets off the chain quick, okay? So I don't know if you guys have ever experienced it. I'm going to kind of go on record saying I've experienced this. I may have let a car go a time or 2 without getting the alignment done because I simply forgot, or we were involved in the Friday Follies or whatever, and those are the ones that come up to bite me. Like I said, little numbers add up to what? Big problems, and this is your biggest problem angle here, okay? So again, it's set positive. As I get out there and build the highway speed, it's going to open up and go to 0. That's the whole objective here. Now, some older front wheel drive cars used to have negative toe, but they didn't handle real good, so pretty much everybody's using positive toe or something that's close to 0, okay? Very dynamic angle, extremely dynamic. Now, will it bring on any kind of handling problems? Yes, it will. Total toe itself will not cause a pull force. Why? Because your toe is always going to equalize. So anybody that tells you a maintenance toe and go is going to create a perfect car that will not pull again is, you know, again, that's that self-proclaimed expert coming out. Because toe always equalizes. Even the rear toe is going to equalize and give you a misdirection, which we call dog tracking, right? And the cars that all have the ADAS on it, if the rear geometry is off, those cameras are looking off into the woods and so forth. I had a hard time trying to explain that to a couple of guys in the booth yesterday and today. Some people just can't grab the concept that if you're lengthening and shortening tie rods in the rear, that's changing the relationship of where that body's going down the road. And some of these ADAS systems, like night vision on an Audi A7, they can see up to 600 meters up in front of that car. So I'm off just a little bit back there, and I'm looking off into the woods instead of at Bambi in the middle of the road. So it's pretty touchy, this toe business. But in the front, if I set it too positive, that's going to cause darting. So what typically happens there, and it's common with a lot of body shop cars where the alignment was overlooked. You drill in, your steering arm's bent, tie rod's got a slight bend, somebody just set the toe like we talked about earlier. Okay, so if it ends up too positive, the tires will jounce and rebound, and at times your tire might leave for a couple of milliseconds, right? So when that happens, what do you think is going to happen? Well, that car is just going to jump to the left. Vice versa, if the right tire is just going to dart off to the left. So that darting with the positive toe can be a very dangerous thing, especially at high speeds. If she's too negative, now it's just going to wander. All right, and these two scenarios here will drive electronic stability control completely bonkers. So you may have a light come on after the repair's been made, you know, again, alerting you that, hey, this thing needs an alignment. But if we back up all the way to the beginning and we perform that pre-alignment check, we could see the toe is out in the front and the rear, and that'll get us on to what we need to do. So again, outside edge will occur if it's too positive, which is toe in, and then your wear pattern for the outside, both inside shoulders will wear if it's too negative, okay? And it does not take long for this wear pattern to set in, and once a wear pattern is established, it's there for the life of the tire. So here's what I typically see with a car that was involved in a collision where the alignment got completely overlooked. Somebody will say, well, go on ahead, get an alignment, and then your tire won't wear anymore. In fact, it might straighten up. No, it's once that wear pattern's there, guys, it's there. And toe is very choppy and aggressive and abrasive, and that chopping pattern that's developed into that tire is going to cause all kinds of nibbles at the steering wheel, vibration forces, and lots of noise, okay? And there's nothing you can do to make that go away. Turning the tires around won't make it go away. Putting the front tires on the rear, sometimes it makes the vibration and noise even worse, okay? And then there's the mother of all evils coming from the rear, thrust angle. See, with all of these safety systems here, again, you're making minor, even if it's minor changes here, you're changing the direction of the body of the car. Now, as I do that, how's that going to affect these wave sensors and cameras? Again, they're looking off to the side of the road or out into the middle. You know, if the body of the car is like this and I'm on my motorcycle over here, it might not catch me until the last minute. And again, this is affecting systems like autonomous braking. What could possibly go wrong there? Well, there's a heck of a boo-boo right there waiting to happen. Okay, so is the rear as important as the front? Yes, it is. All right, now your alignment procedures, you got different alignment procedures, and we'll look at this here in a minute. Okay, the dog tracking is there, but now take a look at what's going on here. I've got 4 tires in 4 different track positions. Is this starting to make a little bit more sense now? What do you think this is going to do to electronic stability control while I'm cornering? So this could be your car where the steering angle sensor wasn't clocked and we've got this mess here going on. This could be the car that's going to give you a drivability complaint. Every time I turn the wheel, this thing is bucking and weaving and acting like it's running out of gas, running out of power. It sounds like a drivability issue, doesn't it? But it could be alignment geometry that's causing this. Usually a car like this will have existing codes that happen right after the accident, right? And it won't detonate one light in the dashboard. How will we ever know if the car has codes? What should we do to this car before we get started? A pre-scan, okay? The Hunter alignment system, you have the ability to hook code link up and do a complete scan of the car before you get started. Now, that's great for the maintenance shops that do corrective and do maintenance alignment, and even for the modified guys. But for the collision repair side, I'm sticking with what everybody else says. I want to see a scan tool, a real scan tool hooked to that car. Because I'm going to tell you straight up, CodeLink is not a scan tool. It's only a device that does alignments, calibrations, and adjustments. It'll read codes, and it'll clear some codes after the repair has been made. So that would be your after alignment thing, that never ever clear a code before the repair has been made, right? Okay. Problems with thrust angles. Here's how we diagnose this. First thing I look at is total toe. If my total toe is at or near zero, that means the axle has shifted, which is common in a wrecked car. If I have a very high total toe number, that means in all likelihood something's bent, and if it's all on one side close to the total toe number, you go to that side and start looking for damages. And again, you can use rear setback, thrust angle, and total toe, all three together, and you can run down the problems with that. I've got a more detailed book with the rear suspension that I use for my diagnostics class. Lots more flow charts. So here's your alignment procedures. Center line alignments, that's what we used to refer to as a front end alignment. If you're using that nomenclature or that terminology, stop it now. Because what that means is you just measured and adjusted the front and totally ignored the rear. Is that a good idea or a bad idea? That is a bad, bad, bad idea. You'd be surprised how many folks out there that are still running with equipment that predates the 1980s. These are the light aligners. John Bean used to have one, it was really popular. I can't tell you how many hundreds of cars I aligned that way, but that's how we did it pre-1979. Even up into like 84, we still had our centerline equipment. So that's what I really learned on, was a used John Bean light aligner. Hunter also has a light align. And you'd be surprised how many times I get a call during the course of the years, hey, where can I buy a light bulb for my light align? I'm like, dude, this is 2019, not 1979. So if you walked in and really looked at the equipment that your sublets are using, it might scare you as well, okay? All right, thrust line alignment. What is that, guys? What am I doing there? I'm aligning the front to where the rear is pointing, which could lead to what? Dog tracking, all kinds of stability issues, right? Okay, I'm going to tell you a deep, dark, ugly secret. Most of the estimators out there that write estimates for collision repair jobs will rate it for thrust line alignment, okay? And I always told my estimators, you know, you got to write thrust line alignment. You can't put a four-wheel alignment on there until what? How do we know there's damage in the rear, guys? Yeah, you got to do your pre-alignment check to prove that there's damage in the rear. So if you're at a low blank 95 cent price, you now know why that's that way, okay? So with the proper documentation, it'll pull you up and out of that rut, okay? Now, what does an insurance adjuster owe? What does an insurance company, owe after the car has been involved in an accident? Any of you guys ever read a insurance policy? A couple of you have, good, all right. I usually ask that question and get deer in the headlight look. A lot of you guys don't even have paper copies that you hold in your hand anymore, right? It's all electronic. Oh, you want to know what your policy says? I'll send you a link. We send it to you in an email and it never gets opened, right? And if you do chance to open it, it's fine print. How do I know that? When I worked for State Farm, I had to go to the Insurance Institute of America. I got an associate's degree from that organization. It's a great organization to tell you how an insurance policy works. It's a legal document. It's a binding contract between insurance company and owner of that vehicle. All right? it states in most insurance policies that they're going to return the car back to pre-accident condition relative to, see, there's mud in the water when we say pre-accident condition, right? In fact, some people say, oh, you can't say that because there's no such thing as pre-accident condition. But if it's paraphrased correctly with the right nomenclature, it is exactly what needs to be said. Our policyholder has to be indemnified for his or her losses, and we restore the car back to a pre-accident condition relative to safety, function, and appearance. Why does it need to be that way? It may have to handle a subsequent collision of like and equal force and get through it the same way. Now, these safety systems, again, they have to function properly, and a lot of stuff gets knocked around. A lot of alignment geometry changes, and so on and so forth. And pretty much everybody out there has a position statement that a four-wheel alignment is a must on cars that have ADAS systems. Okay? So maybe that'll help you out with one of the problems some of you guys discussed on the side. What should we be doing to the car? A total four-wheel alignment. Why? We begin at the rear. We straighten that mess out. Okay? So the rear is projecting what's called a thrust line. And if it's off to the left, it's going to be a negative number. If it's off to the right, it's going to be a positive number on your printout. What we want to establish in the end is once the rear has been adjusted, that thrust line should be directly over top of the center line. And now I've got a car that's basically going to run the road straight, track straight. All four wheels are moving in the same direction at the same speed. Car has been repaired back to pre-accident condition relative to safety, function, and appearance, and should not misbehave from there. Okay? And then the last and final thing, the ADAS stuff. Again, mud in the water. So I'm going to give you my little bit of a take on this ADAS stuff real quick. Okay? And then once we get through this, we'll get into just talking about diagnose and damage, or a little piece of it. If you look up there, that slide kind of says it all. I wanted to put together one slide that I could present for this group and get through this. How many people are displaying ADAS equipment here at these shows? You see it everywhere, right? Okay, what system are we going to end up with? Well, everybody asks me, when is this stuff going to get standardized? It's going to be so much nicer when it gets standardized, right? Guys, that ain't never going to happen. Do we have a standard for TPMS? No. Do we have a standard for electronic stability control? So there's never going to be a standard for this either, and here's why. Some of you folks probably remember back a number of years ago, a certain tire manufacturer in a certain car had an issue. Actually, it wasn't a car, it was an SUV. Had an issue where they were rolling over. You all know what I'm talking about, right? Okay, that was an ugly time, and I was working for the company back then. We actually noticed a pattern and a trend, and it was with several SUVs. It's just that one really stood out in large numbers. So we had to approach them and say, look, you've got a problem. These things are going on their side at a steady rate, and this has to be stopped. Before we got there, the way that our insurance company operated, we did a lot of research to try to figure out, you know, the bottom line of this problem. There has to be a root problem, a root cause, because all of these cars are experiencing the same event. And the event was a rear tire blowout, which led to a rollover, which killed people, crippled people. And I had to deal with that. I got to tell you, man, that was not a good time. When you're working with an insurance company and you have to deal with somebody's mother or father that got killed, or a son or a daughter or a brother or a sister, or even a best friend, it's never a good time. We noticed that the tires were running extremely low on air pressure. Now, if you look back, that particular manufacturer, that SUV, only wanted 26 PSI in the tire when it should have had 30. Now, what happens when you run a tire low on air? The sidewall starts to overheat. Once the tire cannot manage the heat, it does what? It blows out. So if a tire blows out, there's only one thing that caused it, and that's low air pressure, okay? All right. So 26 PSI is way low, right? All right, so we started to do some research on tire pressure to see what people were actually putting in the tires. And when we went around gauging, we did not find 26 PSI in those tires. The average tire had 18 PSI. So who was really at fault in that whole show? The owner of the vehicle who did not maintain his or her tire pressure, and I blame that on self-serve gas. When I was a kid, I worked at a gas station, which was full serve. How many of you guys driven through New Jersey lately? What's full serve mean up there? I just shove it in, I got your credit card in, and I'm smoking a Marlboro while this stuff's going down. I ain't moving around the car or doing anything. That is not what I did. I started the gas, I washed the windows, opened up the hood, checked the fluids, and my last trip around the car was done with an air hose. There was actually a station on my outstation there, and we put 32 PSI in every tire. Y'all remember those days? That's because every tire was bias-plying, about the same size. So we didn't need to look up the tire pressure. So I just set my little crank, reeled it out there, 4 tires, all of that for $2.79 worth of high test. I did tell you it was 1974, right? So yeah, going back a ways. So now we wind up into the future. These tires need air. They're not getting air. Why? Because the attendant's not there anymore to put air in. It's up to you to put air in that little box over in the corner. It's not out there on the island, so it's an afterthought. So if you finally get the urge to put air in your tires, you roll over to the little box and it's like, 50 cents for air? Nah, bag that, I'm out of here. Right? Like the tire's gonna magically air itself. Guys, that's why people were getting killed out there. It was because of air pressure. So what do? Well, one of the guys in our think tank up there at the company that I work for in Bloomington, he actually had I believe it was like a 1990 Corvette that had the aftermarket Eagle GT F1 Goodyear tires on. And when you put those tires on, they were the true EMT run flats. And they put tire pressure monitor sensors in there on band sensors. And he took us out to the parking lot and showed us this great technology. And I'm like, wow, that works. So we actually started working on the TREADS Act, which was the tire pressure monitoring system. And we actually said, hey, it'd be a really good idea if everybody had this system in their car. And once it finally made its way up to the DOT to vote on it, they voted down. Why? You cannot mandate a particular manufacturer. Everybody clear on where I'm going with this? What did that do? That created a what? A monopoly. We were actually trying to pass an unconstitutional law. See, that's what the Senate and Congress does. They stopped us. So we went back and rewrote the bill to get to the root problem. They said, well, you build specifications. That's what you need to do. So the spec for a TPMS system, that system has to alert the driver that the tire is low on air, 30%, that's the danger zone. And a magic light pops on. Then what happens next? Customer goes back to the service station and says, I got a light on in my dashboard. And of course the technicians get all upset because how do they fix the light? They put air in the tire. You know what you just did? You just saved somebody's life. Yes, sir. You know, everybody comes up to me and says, I heard you were one of the guys that helped them get that TPMS stuff launched. Thanks a lot, pal. But like I said, you never want to have to deal with somebody that has you know, a dead relative due to a bad repair or something that was neglected, such as tire pressure. All right? So actually during the TREADS Act, we also started to notice that these cars that had this new system out there called electronic stability control was in play. Okay, electronic stability control hit the scenes about 1998. The first car to use it, believe it or not, was the Volkswagen B5 Passat and the Phaeton and the A8. And then months later, other systems started to go in place, and pretty much all of Europe had it by the early 2000s, 2004. In fact, if you grab your safety systems book, this book right here, and go to page 10 and 11, you will see that the use has increased beyond 110 million cars out there, right? By the way, there are 250 million registered vehicles on the road today, so now more than about half of the cars that you see out there at least have electronic stability control systems on them that have to be addressed after the alignment, okay? All right, so all of these safety systems are coming about, and everybody's got a different system, and you all know that this is on the books for future years coming up, where forward vision cameras and wave sensors that control autonomous braking and collision avoidance is on the table for the next 2 years. So it's this and then some by the time we get out there with this, all right? Now, look at my footnotes down there in the corner. Let's start to make sense out of this, since we know that they're all going to be different. There are 3 different resets that happen. The first reset is a dynamic reset. What that means, and some of you guys have experienced this, you plug a scan tool in, you drive the car, and the scan tool calibrates it while the car is in motion. How many of you guys have been involved in those resets? I've been involved in several of them, and you know, I like the way the system self-calibrates, but I'm not that excited about driving a car while it's calibrating, especially in heavy traffic. What could possibly go wrong there, right? All right. Static resets. There are 2 different types of static resets. That means the car is sitting stationary, not moving. There are several manufacturers out there that have the reset that has to be performed on the alignment equipment, where we calibrate that target board up in front, center to the car, and we square it to the thrust angle, not off of emblems, right? These are more sophisticated cars that have faster stopping power, and these are going to be the cars that you're going to start seeing popping up this year, next year, and the following year to start to comply with DOT standards. So you won't be, I mean, you're going to get a much more accurate, precise alignment of the system, doing it on the alignment system to the actual thrust value. All right, static reset number 2 needs to have a level floor. Some manufacturers have changed the wording on their position statement, and now they say this adaptation must be performed on a level surface, because most manufacturers have finally figured out that there's no such thing as a level floor, right? I have a brother-in-law who worked in concrete, and when they pour these large slabs like you have in your facilities, repair facilities and dealerships and so forth, they flow them out to look good. There could be an inch of fallout in 150 inches, and you would never know it. The middle of your shop might even be a soup dish, and again, you'll never know it. So the floor has to be level, because you're leveling those boards. Those boards have spirit levels to level them, forward vision, back and forth, and side to side, okay? So if you're on an unlevel floor, and let's say you've got a little bit of a downward slope, some of these targets have circles on them. You all see that? The circle will not be a circle, it'll be an oval. The car may pass calibration, but once it gets out there, the camera's distorted because it didn't really see a true image to define the circles. All right, so it might pass the calibration test. So what we recommend after these static resets, you should drive the car for a good 10, 15 minutes. Make sure you get it up to highway speed. Make sure everything's going good with this before you toss the keys back to the customer, spank it on the tailpipe and say happy motoring, right? Okay. If the car is going to fail, you want yourself or a technician in the car that can control that problem and is aware of it. Don't put your customer in there, because all they're going to do is they're going to ride around with their cell phone and say, honey, I'm leaving the shop. Should I pick anything up at the store? Not paying attention to anything, okay? Distracted driving is a real nuisance. So everybody's clear on what is what, right? Again, dynamic, you're in motion. Static with the alignment equipment, You know, what we're recommending now is the new systems that have the rollaway cart that has the camera boom attached to the console. That way you get it out of the way and you have space in front of the rack, okay? Also, we're recommending a flush mount. That way you're level on floor level where your fixture's at, okay? If your rack is above ground, and let's say it's a hunter rack, it's at least 300 millimeters off the ground, which means that fixture may have to be elevated that 300 millimeters as well. If you've got like 4 posters and other folks' equipment, it may be even higher. So the rack issue, you know, that's something you're going to have to put for in your plans, okay? Is everybody clear on this mess here? All right, like I said, guys, there's a lot of stuff out there. Make sure you get out there and look at anything that you can get your eyes on and then make your educated business decisions from there. Don't just look at one and move on, right? There's a lot out there. All right, now let's get into the diagnostic angles. What a beaut. A 1990 Plymouth Sundance. I don't think we're going to be working on too many of them, okay? But that's as close as of an image that I could find for a Camber issue. So I figured the wow factor with the spinning car would at least give it a little more pizzazz. But let's pretend like this is an Infinity, like a Q50, something like that. Something you guys would work on. All right? What do you think a pocket estimate would look like for this car? Let's just focus on the suspension. Let's leave the body parts out. I've got a negative camber issue here, right? What's my pocket estimate going to say? Pocket estimate, by the way, is where you do a snapshot. Estimator's going to look at it. They may or may not take out a mini mag light and stick it up underneath of there. Ah, yeah, something's bent. What's that estimate going to look like? All right, how about this? Give me a strut, knuckle, hub bearing, lower control arm, inner and outer tie rod, left tail light, right glass, clock spring. What am I doing here now? I'm doing and the insurance adjuster always says, oh, I better put the gun down while I'm talking to the adjuster here. The insurance adjuster always says no to that mess, right? Why do they say no? It goes back to the same reason why they say no to the front, the thrust line alignment opposing the four-wheel alignment. If we wrote for everything, we just did something really bad there, especially if one or two of those parts we asked for was not damaged. What did you just do? What kind of fraud? Which is it's a federal offense. Do you all know that the adjuster's real job is to make sure that insurance fraud doesn't happen? That's it. So before he or she puts a part on the estimate, if they document that it's undamaged, they too just committed insurance fraud and could lose their job because of it. And if it gets severe enough, maybe even jail time. All right? Unfortunately, I've seen that a time or two. So here's what your pocket estimate's going to look like. I stick my head underneath of there. I know it's going to need a wheel and tire, a strut assembly, and an alignment. Now, since we can't talk dollars and cents here, you've seen that I put X's up there. So let's play along here. That's not a lot of X's at the end of the day, right? Okay. Let's try it again another way. We're going to use our portable equipment, and within a reasonable amount of time, we're going to do our diagnostic measurements and actually see what is bent. Now remember, we got a camber issue here, so what do I want to look at? What were my two diagnostic angles for camber? SAI and included angle, good. So we're going to roll it up there and we get our numbers. Now, what we're doing here, we're looking at the steering axis inclination, and again, these are the parts that hold the pivoting parts to the car. Now we talked about that strut system earlier. What you'll notice here is wishbone and short long arms. The axis changes a little bit here. See, there's my upper pivot point, which is not the strut bearing, it's the upper ball joint. Lower ball joint down here, so there's my steering axis inclination line. Now what's holding the pivot points in the case of this suspension? Ball joints held with the control arms bolted to the frame rail, upper control arm bolted to the frame rail. So again, it's that C-section surrounding the moving parts and the platform in which it's built onto, okay? So if I've got a problem with my steering axis inclination, in all likelihood in the pickup truck situation there, it's a bent control arm. In the case of that strut, again, control arm could be the strut tower, could be the unibody in general, okay? Yep, ball joint, I'm sorry, good call. So steering axis inclination is not specified. It's just going to be a black number or a gray bar graph. Now, I'm going to heave a political football at you guys. How many of you guys have taken the steering and suspension diagnostic course from ICAR? A couple of you, okay? ICAR's curriculum will tell you to look for 0.5 difference. Guys, I measure new cars all the time, and I see numbers like 0.7, 0.9, 1.2, and it's been that way for years. For years. So I've argued with ICAR. I used to be an ICAR instructor for many years ago. Got out of that, like I said, when I took this on full time. And I tried to get the curriculum changed, and they said, we can't change this curriculum because it's been this way for 30 years. That is not a good reason not to change. So when you see that 0.5 number, please let everybody know that it's 1.5. And that's documented in that book that I gave you there, okay? So you're looking for large side-to-side differences of 1.5 degrees or more in order to find the damage there, okay? Your included angle, again, it's the same deal. You're looking for 1.5 difference in included angle to go after that list of parts. All right, so this should be fairly easy to figure out, right? As long as we have numbers. Okay, so I'll put my 2014 Infiniti Q50 up, and I select it, and this is what I was talking about. This is the position statement that you're going to see right off the bat. What's it telling you? Well, in this case, I've got two resets that are required. I've got the reset for the steering angle sensor, and then I've got the reset for the wave sensor, which is a Robert Bosch wave sensor up underneath of the bumper cover that needs to have a static alignment performed with the alignment equipment, ADAS alignment, with the wheel alignment equipment. It has to be squared to the rear axle geometry. Okay, it's a very sensitive radar. Has to be aligned properly. All right, so right off the bat, because I've done this work, I can add this to the estimate. See how this is taking that pocket estimate to another level. Now I get my measurements. So I pulled the measurements out. This is all we're dealing with, is this negative camber problem that you saw on the right-hand side. Again, what are we looking for? We're looking for large differences of 1.5 degrees or more. What I like to do, and the approach that I've taken for many years while I try to diagnose this work, first thing I want to do is I want to look for what's good. That way, if you take it off the table, it's not distracting you anymore. So this Infiniti Q, let's say it has a McPherson strut suspension. What is good on this car? The steering axis inclination. Now again, what parts are they? So what parts are not damaged? That would be my strut tower, unibody, subframe, control arm. So I now know that if I put a control arm on this car, are the numbers going to change? Absolutely not. They're not damaged. Now, taking a look at that strut suspension, what parts could be damaged? Strut, knuckle, hub bearing, ball joint, right? What's the weakest part, guys? The strut, okay? The strut is a hollow tube, and a lot of folks like to replace knuckles at the same time. So how could we possibly know that this is just a strut? Or how could we possibly know that the knuckle's not bent? Well, we're going to do side-to-side comparative measurements. But at least knowing that the problem is between the pivot points, I'm going to isolate my inspection to the strut, knuckle, hub bearing, and ball joint. Here's how we do this. So there's our suspect right there, bent strut. Checking for a bent strut, you know, some of the ICAR curriculum was pretty good in what they taught you. The little trick with loosening the nut ever so slightly and spinning the top of the strut with the car jacked up in the parking lot. If you see the tire doing this, that's a really good indication that this part right here, your strut rod is bent. Can anybody see the bow in that? You can't really see it with your eye. But if you spun that, you would see the tire going in and out. That's what I had to do with my cell phone on that one. Okay, most of the time though, struts are going to bend right there. That's what we call the tube and sock design. Usually look for cracked paint, and it's always right there at that tube and sock design, at that crease. Because this part here is beefed up, and usually that cast iron or cast aluminum knuckle in there is holding that thing in there pretty good. Okay? How would you know that knuckle's not bent? Well, you're doing your comparative measurements there as well. Simple carpenter square and all of that. Again, some of the techniques that you picked up in that diagnostic course are pretty good. So I'm sticking with them. But I'll tell you this. That little 3 millimeter or 1/8 inch deviation there was 1.5 degrees on that car. Okay? Ball joint studs, if you suspect that they are bent, all you simply need to do, disconnect the tie rod end from the steering knuckle, move it back and forth. If you see the bottom of the base of that suspension moving back and forth, that's a bent ball joint stud all day long. All right? Any questions about that? Now let's back up here. And I want to show you something in your book. You have a diagnostic chart for SAI for the different suspension systems. Okay, so if we go to page 23, insurance adjusters love documentation. Hunter is not going to wind you up in court to the Sarbanes Act and nail you to the floor because you made copies of this and handed it off. We want you to hand this diagnostic chart off to as many estimators as you can possibly do that with. Because the more adjusters that know about this and know what we're getting at, the faster every adjuster will come to the table with a pre-alignment quick check, okay? Now, I've got my numbers here, so I've got an alignment printout, right? You make a copy of this to go with the printout to prove that the strut is bent. How did we get there? The McPherson strut system is in the middle of the page, right? In this case here, camber is 2 negative, so I'm looking at the bottom 3 guys there. The steering axis inclination in this case is okay. So if you look there, ooh, we're on to something. The included angle is too low. What does it say is bent there? A bent strut, knuckle, ball joint stud. The part that's off there that you may want to make a note of, I don't know why it got left off, but your hub bearing assembly is also between the pivot points too, right? So write hub bearing assembly in there. How much of a bend did this suspension system take? Yeah, I'd say at least 1.8, right? Almost 2 degrees. Is that a pretty significant hit? All right, just bear that in mind. I've got numbers, I've got evidence here, real tangible evidence here for a couple of things that we're going to need to add on to this estimate, okay? So again, we go through our quick checks. Let's say we find the strut is bent. That's the only part that's bent. Let's say the knuckle looks good. Now, here's what we're going to do. We're going to write a more complete, thorough estimate. Of course, we need the wheel and tire, the strut and the alignment like we documented for the pocket estimate, right? Now, you performed a task to get numbers, right? What did you do there? An alignment check, all right? So that alignment check, what were the steps that were necessary to go through that? Well, I had to set it up, inspect it, and measure. Because most technicians in the good old days used to look at me and say, hey, I need 2 alignments. No, you only performed 1 alignment, okay? What's the definition of alignment? Inspect, measure, and adjust. Now, we did not adjust here, did we? When you come in and you make your adjustments, that's a full alignment. So if you actually ask for 2 alignments, again, you've committed insurance fraud. So you're going to want to do an alignment check, all right? Which is, you know, I know we're not supposed to talk about money here, but let's be fair about this. Usually it's going to be a less dollar amount than the full-blown alignment because we're not making adjustments. So bear that in mind. What else have I got up there? Underneath of alignment check, what's there? How do I know it needs a hub bearing assembly? Any insurance adjusters out there? Oh, come on. You're an insurance adjuster, okay. Don't anybody throw anything at him or pick on him, all right? I'm your supervisor and you write up for a wheel bearing. What's going to happen next?
How'd you know it's damaged?
There you go. So he's going to get called out on the mat. So 9 times out of 10, when you guys ask for a wheel bearing, you're not going to get it, and rightfully so, okay? Now let's back up and look at a few things. Car's in the parking lot. We're doing our pocket estimate based off of what we're seeing here. All right? Any evidence that that wheel bearing is damaged? None. So here's what would happen. Guys would come at me and go, look, you know, that car needs a wheel bearing. Really? Why is that? Well, before I tell you what I used to hear, I need to tell you what I used to do. As an insurance adjuster, we were not all technicians. I was just one of the lucky guys that was, all right? Sometimes my experience got in the way of me doing some fair things sometimes, and I really had to back up, close my eyes, rethink, okay, what he's saying is making sense. It's making sense. I was a trained listener. And there are certain words that I looked at for buzzwords. In fact, I trained my estimators to listen for 5 words in particular, and if you heard the 5 words, it's going to kill you, okay? And most insurance companies use these practices that I've taught all along, okay? Listen to what I'm about to say, because this is what I used to hear about that wheel bearing. Hey, I think that car needs a wheel bearing. I feel like it needs to go in there now. Hey, if that wheel bearing doesn't go in there now, that car might come back next week. What's that all sounding like, guys? What's it sound like? I'm stating my opinion. The 5 words you never should say in front of an insurance estimator or your customers or a warranty clerk if you work at a dealer. Never use the words think, feel, maybe, might, or could. And there are several other words that stem from that because now you're stating your opinion. Now let's back up. I have numbers here now, right? And I have known parts that I've measured out, and we all just came to the conclusion that I've got about 2 degrees of movement here, right? According to MIT, little teeny organization up there in Boston, Massachusetts, you know, they've got an automotive department and metallurgy and all of that. I spent some time up there when I was working and getting some real education for times when I had to go in work for subrogation. I used to have to testify as the so-called subject matter expert. You can't do that without education. And one of the things I learned while I was up there, that anytime you have more than 1 degree of movement in your camber, the inner workings of the bearing have sustained what's called brenneling. Okay, so what I do to help the adjuster get his or her head wrapped around that, I'll tell them, hey, we're going to go to Google. We're going to Google up the word brenneling, B-R-I-N-E-L-L-I-N-G. And when you Google that word up, you are going to get images of Brenneling is one of the lines that you're going to click on, and that actually has pictures of bearings that MIT has broken down through the years. And there's some really good examples of collision Brenneling that happens. See, a wheel bearing was designed to take up and down punishment all day long, and the whole weight of the car at the end of the day is rolling on that bearing. You know, everybody thinks, well, it's rolling on that tire tread. No, it's rolling on the bearing that's, you know, this thin. So they're super powerful, super hard, which is why Brenneling does occur with that kind of a traumatic force. It's designed up and down all day long, but a whacking from the side, no, that's not going to end too well. And that's what causes the bearing to go up. How long? A week? A month? 6 months? A year? Who knows? You just don't know. But it's a guarantee given that after 1 degree of movement, she sustained some type of inner working damage. All right? So that's why I have that on there. What's that? Yeah. All kinds of information about those bearings out there. So if we put it in now, again, it's going to be an overlap item. The labor is going to be a little low, but what if you have the adjuster that says no? No. If the adjuster said no for that wheel bearing, you want to make sure that he or she documents that on the estimate, that you had that conversation. That way when it comes back, they don't just stick it on there with overlap. Now it's a fresh job. And if I have to dig into this thing and put a wheel bearing in it later, what else out of that list do I have to do? The alignment, what else? Well, if you look down here, we got some other stuff coming here, right? Right, well, we may not have to bleed the brakes. We had to bleed the brakes because on this particular car, when I looked it up, the brake line does pass through a strut that has a little, one of those clip things that it's not just a bolted on thing like most of them do. All right, so if we get down here to our safety system resets, all that's going to have to be redone too. Because you put that wheel bearing in there, what alignment angle is going to change? Toe. What affects that more than any other alignment angle? Toe. Okay? So we've got a reset our steering angle sensor. We know about that because we had the position statement by way on our equipment. You can hit print screen to get the position statement to give to the adjuster, and the position on the adaptive cruise control wave sensor, which is the ICC in this case. And again, the position statement for that. And again, Hunter's vehicle specific, so these are not generic position statements. They are the position statements for this cue. Everybody good? So you see how I've done this? I get all my documentation package together. It's all in order, and there's no guessing about anything anymore. It's all fact. All right, let's try another one. What's bent now? Why do you say it's a control arm? Okay. What does that look like? Well, the camber, positive camber on that right side is poking way out, right? And over here it's straight up. Now let's look at the SAI. On the damaged side it's like 9 degrees, and on the undamaged side it's 12 degrees, right? So as you can see, it's much sharper on the undamaged side. So one of two things happened. Either the top went out or the bottom went in, right? So let's say that this is back to the cue again, McPherson strut. The top of the strut tower went out. How likely? No. No. Let's say this is a pickup truck with an upper control arm. The upper control arm would have to get longer. Plausible? No. So my damage could be because the bottom went in, right? What part controls that? Control arm and cross member. Two good guesses. By the way, those are SAI parts, right? All right. So I'm going to cut to the chase. This is going to go down bottom. Do our comparative side-to-side measurements. You know, he's looking at the cross member. He's measuring the lower control arm. We find out it's the lower control arm. We put that on our estimate and write up all the other documentation for it. Okay? Now, if we back up to these numbers, there's a clue in these numbers. You want to compare your good SAI side with the bad SAI side. Now, there are 3 rules that I teach in my 2-day class that I do for Hunter for diagnostics. And I'm going to give you 2 of them here. All right? When you compare those good numbers with the bad numbers, if the bad number is low, you're going to look low for the damage. Rule number 2 is if the SAI number on the bad side is high, look high. What do we have in this case? It was low. So in this case here, should have led you right straight to the lower control arm. Is this starting to make sense? Right? The devil is in the little problems add up to big problems. All right, here comes number 3. The numbers never lie. Okay? Yes, sir.
So my question is, if you have slight movement, now I know you have excessive movement here.
Mm-hmm.
What transitions you from changing a part to putting on like a camber kit?
I never put on a camber kit until I've looked at the numbers. Now, you remember what I said, I measure cars all day long. Typically, cars that need cam bolts have a higher IA number, right? See, that's what I'm saying. It goes back to the iCar thing I said in the beginning. If they want to say it's a half of a degree, they'll tell you to put a strut in something that may have just needed a mere adjustment or a correction kit, okay? But if that included angle goes up over that 1.5 degree number, you've got bent parts, and you need to chase that down. Never, ever, ever, that was 3 evers, right? Put correction parts in to make up for a bent component, because that's going to lead to a lot more drama than you need, okay? All right, so that was a lower control arm because the number was, again, all right? Let's say this is a pickup truck with a short and long arm. What's bent, guys? Come on. Yep. Upper control arm, she said. Give her a hand. What was that, about 3 seconds? Did you know what SAI was when you walked through that door? There you go. How about them taters? I'm talking like I'm back in South Kakalaki, you know. Again, the numbers never lie, guys. You know, you need good documentations to get through your diplomatic negotiations. These insurance companies are our partners, and we all want to work together, right? Right? As an insurance partner, I always wanted to pay the right amount. And how did I get there? I got there with my numbers. All right? So we do our comparative measurements there. All right. What do you think we got going on here? Huh? I'm positive on one side on the right, negative on the other. Look at my SAI. My SAI is about even up. Okay, I'm going to give you rule 3 for free. If you've got cross camber, what's cross camber there? That's 1.6, right? Negative 0.8, positive 0.8 is 1.6 difference. And if you look at the difference in included angle, it's 1.5. If your included angle and your cross camber are the same, that is a shifted subframe all day long. So I get these questions. That's a normal adjustment for some cars too, by the way. How do I know when I have to shift the subframe? There's your answer. Okay, so again, it's all in the numbers. So cradle shift will take care of both of that. And you know, some of these cradles have some pretty large adjustments. Some of them, like your Volkswagen products, will advertise a cross camber split, but it's very difficult to get those cradles to move. If you're going in raised selected axle feature, you jack it up on the body, takes all the weight off, okay? Now, I'm just gonna run through these real quick. Again, setback, what we do there, we look at the position of the tire, and if you have setback on the same side that you have a caster problem, that's a bent control arm all day long, all right? So your setback is your direct correlation there. So again, if it's a negative number, what that means is you've got setback on the left side. If it's a positive number, it means you got setback on the right. So here we go. I've got negative setback, and on my left caster, it's way back. What do you think I've got going on there? Wheel setting back, caster's back. What part do you think's damaged? That's a lower control arm all day long. Let's do some comparative side-to-side measurements. Sometimes you can physically look at it. Yeah, that was a picture I took back in the day. Right? A little twisted there, right? Okay, the control arm was damaged too, so it wasn't just a replaceable ball joint. To measure setback, you get into additional measurements, walk that through. You also get your offset values and all of that. There's another example there. That was actually a shifted subframe. Okay, rear setback, again, that's used for any drama that I have in the rear, thrust angle that I can't get out. And your thrust angle in these new cars nowadays have to be somewhere close to 0. And if you use your setback, you can also pick up things like diamond frames that occasionally happen and more severe damage like that. So if you pick that up on an audit, then you really know you got some work to do with your framework there, okay? And of course, your offset values are going to come in at the same time, okay? Moving on to turning angle and what it does, again, it's measuring the position of that steering arm. What Ackerman is, if you were to draw a line straight through this rear axle, straight from this spindle, all three of those lines should come to the same point if your toe geometry is correct and all of that. Again, the piece that controls this is this little steering arm here, a minor bend there, and again, a technician either lengthens or shortens the tie rod. That leads to a bad experience there. Now, some of the older cars and some of the newer cars are going back to this, and some of your medium duty and heavy duty trucks have a separate serviceable piece for a steering arm, but for the most part, it's on the knuckle, and on some cars, it'll be on the strut, okay? And again, I can accommodate that bent part just by simply lengthening or shortening the tie rod, which is what most maintenance sublet shops would do. So again, it has to be equal from side to side in order for that geometry to maintain itself, and steering arms will typically bend like right inside the sweet spot there, so look for your corrosive hot spots and your measurements there as well, okay? Another indication, the tie rod lengths are not the same, okay? Or you could do the simple finger test, right? Or the carpenter square to verify the bent side, okay? And then of course, you know, depending on whether the tie rod is on the front or on the rear, that's gonna tell you which side is actually damaged. Your max steer, again, you see the drawing up there at the upper right-hand side. Even when I steer the wheel to full lock, all three of those spindle lines and rear axle lines should all come to the same point. Again, if they do not, excessive tire wear and all kinds of steering and return problems. These are usually the cars after they've been wrecked that, you know, in the parking lot, I can turn it right into a left-hand spot. If I turn into a right-hand spot, I have to back up 2 or 3 times before I can finally get her in there, right? Okay, so there's ways that you can do that. You know, turn the wheel. Usually most cars is, you know, turn and a half to the left, turn and a half to the right, and then turn it back equal amounts, see where your steering wheel's at, and go from there, okay? So, let me go back here. Your max steer, what these numbers should do, they should cross and come within 1 degree of each other. If they do not, you've got a centering problem, okay? So, I think I actually held you guys over a minute or two. I apologize. No, I'm right on time. There you go. I didn't prevent you from getting to that adult beverage of your choice. But I really want to thank you for coming out and sitting in here listening to me run my mouth for 2 hours. And I wish you guys would stop by and see me at the booth.